Hi, my name is Shufan Kang. This is a demonstration video for the ECE461. The challenge assignment 1. Here, I will first show you how my code, explain you how my code works. Let's go to the main. First, I will initialize all the GPIO pins. As you can see here, I firstly initialize the pin 1.1 which is switch 1. I set it to input pin with pull up resistor and enable its interrupt 13, and then I set the pin 2.0, which is red LED, as output pin, and set its output to low initially. Same as the green LED, I set it to output and initial to low. And then I initialize the time system. I first set the system reference clock to 128 kHz, and then I set the A clock with a divider of 1, which set the A clock to 128 kHz as well. And then I divided the clock source by 4 and set the SM clock to 32 kHz. Then I configured timer A to continuous mode. Here is the detailed configuration. I set timer A clock source to A clock and with a divider of 1, which will perform 0.5 second per interrupt, and I enable the interrupt 13. And then I enable the time interrupt and start the time A0 counter. Here I set AB in hex to all the data array. This is the data array that I'm going to program into the memory. Here I enable all the interrupt. Here I set the watchdog timer A with a clock source of SM clock and integration of 32K, which is the actually same as the SM clock. So since the SM clock with 32K kHz and the iteration is also 32K, so which means 1 minute the watchdog timer will times out and start the timer. And here I will turn the LED on to tell the user the system start. Here I clear the LED counter and do a 1 second delay. As you can see here, the timer A0 interrupt server routine. I clear the watchdog timer every 0.5 seconds, so the watchdog timer will never expire, and increments the flash counter and LED counter by 1 each 0.5 second. And yeah, this will turn on red LED for 1 second. And I clear the flash counter here, so I will gonna be wait here until it arrives 1 minute. Here I will erase all the memory in the erase all the all the 128 memory. As you can see here, I will firstly unprotect all the sectors in bank 1, whole bank, and perform a mass erase. So it will erase the memory into FF in hex. And I check the data in memory bytes by bytes to see if it's FF in hex. If it's not FF in hex, I will return 1. So here the in the while loop, I will do the erase again. Same here, the program memory. I divide the 128 kilobytes memory into 32 sector and program the data array that I declared before into the start address of the bank 1 sector, and after this sector finished, I will increase it by into the second sector, and this block of code will verify the data and the data in memory to see if it's equal. This is a byte by byte. This is a byte by byte comparison. If they are not equal, it will return to 1, which is same as the erase memory. It will do again. After the program successed, I will turn green LED on for 1 second and do a 1 second delay and turn it off. And I will stay here until the flash counter arrives 1 minute. Yeah, that's pretty much the code. Let's do a debug. I will set 2 breakpoint, one in the erase memory, another in the program memory to show how this works. Let's start the code. Let's check the memory window. Since these 2 statements was executed, so the memory was erased into FF in hex, and as you can see here, in the watch window, I set the data in memory have a value of FF, and its address is 20,000. And let's go step into. As you can see, this loop will go through all the address in memory until 40,000. So this will verify if all the data was erased. Let's remove this breakpoint and continue. As you can see here, all the FF changed to AB, which is the data array we declared. However, this is only 1 sector. If we go down here, the second sector is still not programmed yet. And in this loop, I will verify the data byte by byte. As you can see here, all of them are AB, and I go through all the address here. As you can see here, I changed to go through another sector so. Let's continue. Let's remove the breakpoint and continue. Actually, let's see how it works on the board. yeah, let's yeah, um, let's restart the board. As you can see here, after I press the switch 1, the red LED turns on for 1 second. Since I have a little bit low system clock, so it took a little bit while to erase all sectors, to erase the whole bank. Yeah, as you can see here, the green LED turns on about 1 second, which means the erase and the program succeed. And it should be turned on again after 1 minute. Yeah, it's the green LED turns on again. It's actually exactly 1 minute. And I can also show you if I press switch 1, the red LED turns on for about 1 second, which means the system reset. I can do again to show you. Yeah, here. Yeah, that's all about this demonstration video. Thanks for